All right, so I'm very excited. It turns out that I don't know that it's my coils that are the problem. So right now I've got it hooked up, single coil, to a hall sensor. And as you can see, it is flying. And I'm not even at 12 volts. I'm actually going to turn it down a little bit. You know, the hall sensor obviously has to be set up in the right spot. It took me a couple of tries. If I lay it flat, it goes really slow, but the more I tilt it back, the faster it goes. Because the hall sensor is very sensitive. And these are some powerful magnets in there. But yeah, I bet you I can get some good output by placing the other coil on top. So let me try that. But as you can see, this thing is flying. I mean, it's really flying. So yeah, I'm kind of confused. Using the JL94 on a single coil, I don't get anywhere near this type of speed, even with the double coil. And we can tell that the rotor is in terrible shape. I'm going to I have to actually hold this down. But she's flying. The circuit's getting warm, but not too bad. I can still touch it. So the next experiment would be to place the other coil on top and see what kind of output I can get off of this. All right. All right, so as a pickup coil, this second coil here doesn't do much. Gives me like a couple of volts AC. Not sure why that is. Yeah, if I... Oh, sorry, my big goofy hand's in the way. Yeah, it's not giving me a lot of output voltage in the AC area. Let me turn it off because I've had it running for a while now. The circuit's getting hot. So this lower coil does great as far as running the hall circuit. Does okay with the JL94, but much better with the hall circuit. So I think the next thing I'm going to try is I'm going to build a rotor, a different style rotor, something like this that will run in this capacity here, like this. Or I don't think I can make one that'll fit whoa, I don't think I can make one that'll fit like this. It'll have to go like this. And see if I can get the JL circuit. I'm also going to try the JL circuit on this beast right here. On this guy right here. You guys remember this one from before. See how the JL circuit works on that one. I think that's the next one I'll try. Well, this is the beautiful coil that Sky made. We know the circuit works. The coil has to be of a certain ohms, because this is at 11 volts, and I'm even dropping it down. There's 10 volts, 9, 8 volts. There's the load. And she's flying. And the coil's not even close to it. So it has to be the amount. I put 1 pound of wire on this thing. So it has to be the distance, because this weighs about the, well, it weighs obviously more than this coil, but that's a heavy coil. So let's see what the ohms reading is. Let's turn this off. And let's take this guy off of here. All right. Let's see what the reading is. I'm not very good at this, so I have it set, and I have a 100 ohm resistor. Oh, come on. I have a 100 ohm resistor, so let's make sure that my setup is correct. All right, so I have a 100 ohm resistor. I'm all tangled up here. Sorry about this. And there it is, 97. All right, 98. So let's see what this guy is. Why the hell is it all over the place like that? Let me see if I can. We'll call that about, what was that again? We'll call that about 10 or 9. And then this beast is about 9. Yeah, so it must be the distance. It's got to be the distance, I think. Anyway, I'm going to build a new rotor because, and I'm going to still play around with this guy. I'm going to build a different coil. I'm going to build one of the typical window motors coils that are not housed in any type of frame, but come under, up, around, under, up, around, under. So I'll have to figure out what size to do that. And then just wind that one, hell by hand. I can just, because I'm just going to tie it up and then mold it around the base there. Anyway, ciao. So I love playing with this circuit. It is a great circuit, and I really love that coil. So this is the JL94. There's the load, and I'm using my large maglev. And what's really unique about this particular coil and this setup is that if I try to start this, it's at 8 volts right now. So let me juice it up. It's 12. If I tried to start this with the coil down here, it wouldn't start. But if I bring it up to it like this and catch the coil like this and then lower it, it stays connected, or it stays in sync, or whatever it is. So yeah, maglev success. I got to build this other rotor though. I have to figure out how to build. Let me turn this off. I have to figure out, I need those parts from a VCR. I think I'm going to have to take apart one of my other older rotors. Anyway, stay tuned. All right, so I've got an interesting predicament. So I made this guy, which is really cool. And he'll sit inside here like this, right? Or yeah, he'll sit like that because he can't sit like this. But he'll sit inside there like that. I'll have this up. The only problem, some of you who have worked with these will know, you see how it's clogging or cogging? I forgot that there's a magnet, a very weak magnet, but a magnet nevertheless inside this VCR head. Yeah. And so it doesn't really hurt it too much, but it's not as free flowing as it could be. It's cogging big time. So now I did a lot of work on this. This was hard getting it to this point. It took me a couple of hours, but I guess it wasn't that hard. And we got north south, north south. I don't know if I should go on with it the way it is or try to take it apart. Every time I've taken these apart, I've always messed them up. I could not get them back to this pristine shape that they're in now. And I don't think the clogging is going to hurt it too much. I was kind of worried because in the cogging effect itself, here, let me show you. Oh, actually, it's not too bad. It's not too bad. When it's stationary like this up against something solid, it's not too bad. When I have it up here, I can actually feel it jerking like that. So let me try it like that. Yeah, I gotta be careful. These freaking magnets are strong. I've already messed myself up. All right, stay tuned. All right, so I had another issue. Along with the cogging that the magnets were doing, they were also hitting. I thought I had drilled far enough outside, but I didn't. And I couldn't, and actually I really couldn't, because there's a ridge inside there which causes, anyway. What I decided to do was cut out a acrylic disc. I've already tapped these. I'm going to drill this out, tap those, and then put the 4 magnets there. So I think that'll do 2 things. One, it will stop the cogging because it'll be far enough away, and it'll give it a better seat. The magnets will have a better seat because I'll be able to really go in there. So hopefully the next time I talk to you guys, it'll be showing this thing in action, but maybe not. Who knows? Yeah, it's not every day I get it first shot. So now I just drill the holes and I should be golden. Yeah, that should definitely stop the cogging. I have to, I gotta tighten those down. Actually, I gotta put tiny washers underneath there. I drilled the holes too deep. That's all right, though. It's not hitting. See, the problem with putting in here, I don't know if I mentioned it before, no matter how shallow I got it in there, one of these was always hitting something, too, other than just the cogging. I was able to back it out enough, but that's not safe. So yeah, like that. Magnets. This guy will be like this. There you go. This guy will be like this. Or like this. And we will see if the JL94 will work with this setup. The magnets I'm using are these cylinder magnets. These are N52. Very powerful magnets. I think they're 3/4 by 3/4, or no, actually these are a little bit longer. These are 7/8 by 3/4, I think. Let me, where's my, yeah, something like that. Where is my inch scale? There we go. Hate using metal magnets with, oh, it's 1 inch by 7/8 or 3/4. Yeah, so they're pretty powerful. And then I've got these other ones. I'm just going to put 4 on here. I was going to put 6, and I thought no. And then I've got these. These are 7/8 by 7/8, I believe. Yeah, 7/8 by 7/8, and 52s as well. So, just wanted to show you the progress. It'll sit like that. It should be pretty square. Oops, sorry. All right, ciao. So I can't work on my on that rotor anymore. Where is it? Yeah, I can't work on this guy because I'm missing two types of screws. I want to use these brass screws, and I only have two of them. And unfortunately, my is closed. So I figured I'd play around. So here's that Bedini motor that I bought, and I want to see if it works with the JL94 circuit, and it does. Works really good. Well, it works because of this coil. That's why it works. This is the coil that I got from Sky. So the circuit works great. Which still tells me about my about this coil. But it's funny because the coil worked good. Oops, the coil worked good with the Hall sensor. Oops. Yeah, here's the load over here. Circuit's nice and cool. 12.5 volts. I could probably turn this way down. So let me try some of my other crazy rotors and see what they do. Yep, that crazy rotor works. I can definitely turn it down. That's about 11 volts. I could probably turn it down. But there's the load. Coil staying nice and cool. So I love that JL94 circuit. That thing is freaking great. And if you guys are wondering what I mean when I say JL94, these two chips right here. So this is a 94 and this is a 93, or vice versa. And they're both, one is an, I'll have to get the right verbiage. I think one is an MPN and the other one is a tip. I'm not sure. But Sky, I guess, invented it or figured it out. Huh. So this gives me ideas for a lot of stuff. I wonder if it'll work with the big rotor. Hold tight. Yeah, so the circuit works with all my rotors. This is the one that I had built my first Bedini circuit, or tried to. So yeah, the whole secret is the good coils, or the good coil. And it, I think it self-oscillates if I stop it. Listen to this. Let me... Oh, you guys can't hear it. Ay, ay, ay. I want to ruin this thing. Yep, there it goes. And there's the load over there. 12.4 volts. So this this JL, I think it's JL94 circuit works on anything as long as I'm using a coil with high coil with a certain amount of ohms, certain amount of resistance. This is running nice and smooth now. Really smooth. The circuit's nice and cool. It's flying. Let's see if I can get any type of reading on it. About 5,000 RPMs. Yeah, I can actually put it down and it'll still work. Let me see if I could. Ooh, 9,000 RPMs. Oops. Yeah. It's a great circuit. Works freaking fantastic. Yeah, I'm bored because I can't finish my rotor. It's driving me crazy. Freaking Ace Hardware closes at 5 o'clock now because of all this social distancing stuff and, you know, yada, yada, yada. Which I get. I get. All right. So I haven't tried the JL94 circuit on my little maglev. Kind of bouncing around a little bit, but it's screaming. Let me see if I can get a reading on it. It says it's 3,000 RPM, which is probably true because it's not very close to it and it's kind of back up. But yeah, this is a great circuit as long as you have a really good coil. So I'm gonna have to rethink how I make my coils. I'm just gonna have to use a lot more wire. Although I don't think that that's the problem with this one here. I still believe it's because it's too far away. It still works, just doesn't work as well as I had hoped. But we'll get it. We'll get it. Everything's a learning. It's all a learning thing. Here's the load. I got these things online. They're 12 volt LEDs. I have to build a couple of rectifiers. Actually, I have a couple. I just have to test to see if they're okay. All right. I think that's going to be it, man. I'm bored. I wanted to finish that rotor today. Going to have to wait till tomorrow. All right, guys. Ciao. I had to do it just one more time. So here's that big ass rotor of mine with a real good coil. This thing freaking screams. There's the load. 12.4 volts. I could probably turn it way down. Yeah, this thing had to do it one more time. Couldn't help myself.